Hi, this is Alex from devstories.eu. Async.io, episode 9 of 20. You have 50 tasks waiting for a database to connect. You definitely do not want them polling in a loop, wasting CPU cycles while they check if the connection is ready. You need a single broadcast signal that tells all of them to start querying at the exact same moment. This is exactly what coordinating state with events and conditions handles. An async.io event manages a simple internal Boolean flag. It starts as false. Before we look at the flow, let us clear up a common confusion between events and locks. A lock grants exclusive access to exactly one task at a time, keeping others out. An event does the opposite. It notifies multiple waiting tasks simultaneously, letting them all proceed at once. Think about that database connection scenario. Your background task is working to establish the connection. Meanwhile, your 50 worker tasks reach a point where they need the database. Each worker calls the wait method on your shared event object. Because the internal flag is false, all 50 tasks suspend. They sit idle. Eventually, the background task succeeds and calls the set method on the event. The flag becomes true. Instantly, all 50 suspended worker tasks wake up and resume execution. If you need to shut down the connection later, you can call the clear method on the event. The flag goes back to false, and any future calls to wait will block again. You can also check the current status of the flag at any time by calling the isSet method, which returns true or false without blocking the task. That covers simple broadcast signals. Sometimes a single Boolean flag is not enough. You might have multiple tasks that need to wait for a shared resource to reach a specific complex state, and they need exclusive access to safely check or modify that state. This is where asyncio.Condition comes in. A condition is built around an underlying lock. To do anything with a condition, a task must first acquire it. Once acquired, the task checks the shared state. If the state is not what the task needs, the task calls the wait method on the condition. Here's the key insight. Calling wait on a condition does two things at once. It releases the underlying lock, allowing other tasks to access the state, and it suspends the current task. While that task is suspended, another task can acquire the condition, change the shared state, and then call the notify method. The notify method takes an argument specifying exactly how many waiting tasks to wake up, defaulting to 1. You can also call notify all to wake up everyone at once. When a suspended task wakes up, it does not just immediately run. It must wait to reacquire the underlying lock before the wait method returns. Because another task might grab the lock and change the state before the awakened task gets its turn, the wait call is almost always placed inside a while loop that continuously checks the desired state. Once it has the lock back and the state is correct, it can safely proceed and eventually release the condition. When deciding between the two, remember that an event is a simple broadcast telling tasks that a one-off action happened, while a condition allows tasks to safely wait for a complex state change without constantly polling a locked resource. Thanks for spending a few minutes with me. Until next time, take it easy.